Let's take a look at this question of kinematics with trigonometry. A particle moves in a straight line so that t seconds after leaving a fixed point B, its displacement as meters is given by this expression. I want to find the displacement of the particle when t is 1.1, and how I'm going to do that is very easy. I will let t be 1.1, sub it into s. The trick here for subbing in is that for angles, like for example 2t, I will immediately multiply t by 2. So 2 times 1.1 will give me 2.2, and I can key into the calculator immediately. The answer is 6.53 meters rounded to 3 SF. Part 2. I want to find the expression for the velocity as well as acceleration. So if I'm given displacement only, how am I able to find velocity and later acceleration? So based on our notes, we have to differentiate first. Differentiate displacement to get velocity and differentiate velocity to get acceleration. So let's do that. Let's differentiate displacement with respect to t to get velocity. 3 plus 8 cosine 2t. That is our velocity. And now for acceleration. Acceleration is to differentiate velocity with respect to time. So differentiate one more time using PTA. The answer for acceleration is negative 16 sine 2t. Now let's count the part 3. I want to find the distance of the particle from B. And the distance from the fixed point is also known as displacement. But keyword here is when it first comes to rest. So comes to rest, we can think of it like instantaneous rest. And what happens at instantaneous rest? What happens to velocity? Velocity would be 0. So let V be 0 for part 3. So now we'll do some trigonometric solving. Key thing here is to make it single trigo, meaning single cosine. And afterwards, we have to find our reference angle. Cosine inverse the absolute value, 3 over 8. So let's see, should we calculate in degree or in radian? So for any kinematics question, we need to calculate in radian because it's a real world problem. So please set your calculator to radian mode. The answer in radian would be this, 1.186399, and it goes on forever. Try to write at least 5 significant figures. Based on ASTC, since cosine is negative, it would be in quadrant 2 and 3, which means 2t will have two values, pi minus alpha and pi plus alpha. These are my two answers, which leaves two values for t when I divide by 2. So I have two answers for t. Which one should I use then? So if we scroll back up, what does the question want? We want the distance of the particle when it first comes to rest. So I will take the first time value. That will be this value, and I will sub this value into s. And the answer for displacement would be 6.64 meters to 3 SF. And we are done with this question.